then, and S wave arrived then. So P wave probably arrived, what is this? So this is 8, this is 8.5, and this is 9. So P wave probably arrived around 8.6. And then the S wave probably arrived around 15.4. So I know it's hard to get very specific, but try to get it within 1 decimal point. Otherwise, your graph is going to look really weird. And make sure you're doing this again as decimal points, not as minutes and seconds. Okay? All right, so that is how you're going to go about doing the first part through all of the locations. So some of those locations, again, are not going to be on figure 5A. Some of them are going to be on figure 5B, which is on page 80, but you do it the same way that we just did it for those 2 locations. Okay, so after you do that, he wants you to go ahead and, we already did this steps. So we open the Excel spreadsheet and we use the diagram to determine the arrival times of P and S waves. And then we also included the distance within that spreadsheet. Okay, so once you have a P and S wave plot complete, follow the printing instructions outlined in the plotting your results. So that part you're not going to do since you don't have a printer, or you might have a printer. If you print it out, great. If not, you can just have it in your screen. It should do the same. It should do the same job for what we need it for. So go ahead, grab your graph once it's looking good. It should be a relatively straight line. It might be a little bit curved, as you'll see later on, but it shouldn't have any weird bumps or anything like that. Okay, if it does, go ahead and check your data again. Make sure that your distances are correct, that your locations are the right location, and that you have the correct P and S wave arrival times. Okay? Okay, so this is my particular resulting graph, one of the 2. I'm not going to show you the other graph because that's going to be part of the answers or the possible answers to the online quiz. But this is my resulting graph from the P-S wave arrival difference, okay? So both of them have been basically plotted against one another here, and the difference in time of arrival is what you're seeing. So what you're seeing again on the x-axis is the distance from the epicenter, and then on the y-axis you have difference in P-S wave arrival time. So what that means is that with increasing time, you have increasing distance, okay? Which makes sense. The farther something is from an earthquake, the longer it will take for those seismic waves to arrive to that location, okay? So you'll see that the other graph that you get where you have the P and S wave as 2 different curves, they'll be a little bit different. One of them is going to be steeper than the other. So I want you to think about why would one be steeper than the other? How much time is passing versus the distance that is being covered by each, okay? And that's pretty key. So if you have any questions, again, I'm available through Blackboard Collaborate Ultra or through email at any point. Okay, and lastly, let's go through how that looks on your quiz. So if you go onto your quiz again, click begin. Only do the quiz once you have the answers for all of it, okay? So this is question 15, or sorry, question 1, which in your lab manual is really question 15. So those are the 2 different waves plotted in that graph. So here I'm asking you to label them and tell me, yeah, pretty much label the 2. Okay, second question, which is question 16 of your lab manual, is asking you, this is a graph that plots time against distance, the one that you just got. What is a common ratio that has both a time and a distance component? So that's up to you to choose. Question 3, which of these lines is steeper, and why do you suppose that is? Okay, so that is where I was telling you that it's a pretty key concept to get. So hopefully by having listened to lecture, you will be able to answer it, but if not, and you're still confused, go ahead and ask me. I have no problem helping you out. Okay, question 18 of your lab manual, question 4 within here, asks you to go ahead and do a short answer. Same thing. Oh no, just that one. Okay, and question 19 tells you a hypothetical. So let's go through that hypothetical together, through a different hypothetical, basically. So, if an observation station in Boise, Idaho, recorded a P wave 6 minutes after an earthquake, and then it recorded an S wave 12 minutes after an earthquake, how far away would the epicenter be? So, using that graph that resulted, showing you time versus distance, that's how you're going to be able to find out how far the earthquake really is. So let's go through another example. Not the same one because I don't want to give you the answer, but through a different example.